Okay, so here I'm talking about organic chemistry, and the topic that I'm going to discuss is chemistry of hydrocarbons. The actual topic is homologous series. So here the word homo means same and logos means to study. So here the study of hydrocarbons like the same group is known as homologous series. So there are some properties, or you can say characteristics, for this homologous series, and the first one is the general formula can be used to describe all the member of series. As we all know, there are three formulas: alkane, there's alkyl radical, but we will study it separately, alkene, alkyne, right? So the general formula for alkane is CnH2n plus 2. I'll tell you how to make the compound from the formula later. CnH2n, this is the general formula. What is this? General formula, right? And talking about alkene, so it is CnH2n minus 2. Sorry, I make this big. It would be small, right? So now talking about the second characteristic. So the second characteristic is they have same chemical properties. Now same chemical properties. Now listen to me carefully. I'm talking very conceptual thing. Here I'm not comparing these three like the same chemical properties. I'm not comparing alkane, alkene and alkyne. I'm only talking about alkane group. Like whole the alkane group would have same properties. Then talking the same goes with alkene. Here they have same properties. Never think like I'm comparing these both. No ways, not at all. I'm talking about the separate groups. Alkane, alkene, and these will have same properties. The whole group. I'll explain you how. Like when I'll tell you how to make the formula, so you'll get it properly. So now let's move to the third one. That is like their physical pattern evolve in periodic pattern. Like they have periodic pattern here mean they have same melting points. Melting, boiling, point rise, point how much point with rise, like they would have the same. Like alkane would have the same. A little different would be there, but almost they would be same. Same goes with alkene and the same goes with alkyne, right? Now the fourth one, they are prepared in similar manner. I know you may get difficulties cause I am just saying here I haven't made the formulas yet, so that is why. But now I'm gonna be making the formulas like they are made in the same pattern. Of course, when we have the general formula same, so in everything like first of all let's talk about methane. So C1 it will be double 2 and 2 plus 2 4. Talking about ethane, so it will be C2 2 plus 2 4 and 4 2 2 are 4 and 4 plus 2 6. So in this manner they are same. Let me write this here as well. First let's talk about methane. ANE, as I told you, methane ANE means single bond, right? So methane C1H, here's the general formula: 1 plus 1 2 are 2 2 plus 2 4. So this is methane. Now talking about ethane, I apologize for the spellings, but let's go with the concept, right? Eth has 2 carbon. Here we'll put 2. Let me tell you how to use it. Like here we'll put 2. Now 2 into 2. Here we have to multiply 4, right? Now 4 plus 2, 8. So this is ethane, and same goes with the alkane. Alkene, as I told you, these are double bond, and alkyne, YNE3, right? Now let's talk about how to make the formulas using this. First of all, let me tell you how to, like here the homologous series ends. Now remaining alkyl radical is remaining, but I'll tell you first of all, let's go with alkane, alkene and alkyne. Then we'll come back to the alkyl radicals, right? First of all, alkane. Like here I'm showing how to make. Okay, so I was telling you how to make the formulas here. So how to make the compound from alkane formula, right? So let's move now. As we know that the formula of alkane is CnH2n plus 2, right? So the trick to learn, CnH2n plus 2. So the tricks to learn for organic compound is like there are 10. Of course there are a lot of, but the main are 10. First of all, learn meth, ETH, prop, bute, pent, hex, hept, oct, non, dec. Right? You have to learn it like meth, ETH, prop, bute, pent, hex, hept, ect, non, dec. These are the 10. These are the most like important, or we use it mainly. Now according to the bond, place it. For example, here ANE, 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 right? According to the bonding, do it. For example, here I'm using the formula of alkane, so here it will be methane. But if you are using the formula of alkene, so you'll use it methane. And if you are using the formula of alkyne, so you have to use methine. Okay, so let's make the formula. C, as we know, 1C, 1 plus 1, 1 2s are 2, and 2 plus 2, 4. This is the formula of methane. Now talking about ethane, so eth mean 2. Okay, so same goes with the hexene. Here it will be C6, H14, and C7, 8, 9, 10. Now double it and add it. It will be 18, 20, and 14. It will be 16, 18, 20, and 22. So here is the formula of alkane. Now talking about alkenes, main double bond. The formula of alkene is CnH2n. The same goes with like methane, ethane, all will go with it. Only ANE will change, right? Here ANE will change. For example, meth, ENE will use ethene, propene, butene, pentene, hexene, like this. So here the formula is CnH2n. For example, C1H2. Same goes with C2H4 as C3. Now 3 2s are 6, C4 4 2s are 8, C5 5 2s are 10, C6 6 2s are 12, and so on. It will be same for the alkenes. Okay, right? Now talking about